again, these are still going to be talking about our different trig ratios and how we can use them. A lot of our notes were already yesterday, so I want to do a lot of examples today. So everything today based or stems off of what we did yesterday, okay? No, there's no story problems today. All right, so here is example number 1. Yes. Not super soon, though. Okay, you're going to be all right. Okay, you guys ready? So, in this one, we are going to talk about the 29 through 39. And it is going to ask you to evaluate using a calculator. But here's a couple things I want to point out. Your calculator has 2 different modes. There's degrees and there's radians. You are going to be bumping back and forth between the 2 depending on the problem, so you got to pay attention. Okay? So for example, if I want you to find the cosine of 18 degrees, first thing you're going to do is go into your calculator, make sure you're in degree mode. Make sure you're in degree. Then you go ahead and go to cosine of 18. 0.951. We'll start there. 0.951. Did everybody get 0.951? Okay. Yeah, if I ever get to keep talking. Huh? So what if I said I want you to find the sine of pi over 12? That's a radian. So now go back into your calculator, change the mode to radians, and then hit your sine parenthesis and put pi divided by 12. Pi is on your caret button. Yeah, 0.25888190 and so on. Okay? So the 3 easy trig functions to do on your calculator are sine, cosine, and tangent. Those are right on your front screen, right? Right on those easy buttons, but we do have 3 other ones we need to discuss. Okay? So, if I wanted you to find the secant of 20 degrees, first of all, secant is the opposite of cosine. So what you're really going to put into your calculator after you make sure you're in degrees is 1 over the cosine of 20 degrees. Okay. Nope, because that's not the same thing. Okay. When you have that little, and I want to talk about that really quick, on your calculator when you have that little -1 hanging out in here, what that means is you're looking for the angle. It helps you find the angle to the cosine, not the opposite of cosine. Okay? That's why we need a snow day. All right, how about one more? Let's do the cotangent of pi over 4. Back to radians. Cotangent is going to be 1 over the tangent at pi over 4. One is correct. we clear on how to do this group of problems? Go ahead. What's your question? Because these secant, cotangent are not actually on your calculator. So in order to put them in the calculator, this is the opposite of cosine, so that's why we put it to the bottom. This is the opposite of tangent, that's why we put it to the bottom. Okay? So if I had a cosecant up there, that's the opposite of sine. We move sine to the bottom. Okay? All right, so we're good? Oh, they're having some issues next door, I think. All right, example number 2. Example number 2 is going to cover your 41 through 47. Yes. So in this one, okay, let's keep going, and I'll go check on them in a minute. All right. All right, in this one, I want you to find theta. Seems pretty easy, right? Yes. So I have the sine theta equals 1 over 2. Nope. So we have 2 possibilities, 2 different ways to do it. I want you to put it in both degrees and radians. So all of your answers in this section are in degrees and radians. So you should have 2 answers. Okay? Remember what I just told you was that in order to find the angle, you had to use that little -1. So what I want you to take is grab your calculator with a little -1, so you have to do the second sign. And then in this, you're going to plug in your 1 over 2. Just a minute. So, here's the thing, is I first want it in degrees. So make sure your calculator's in degrees and do it again. Yep. Uh-huh. 30 is correct. So once you get it as 30, how do we change that 30 degrees into radian measure? Times by? Yes, we would take this 30 times by pi over 180, and you get pi over 6. So those are your 2 answers you should get. Okay, let's do another one. Yeah, I think so too. How about, let's do the cosine theta equals square root 2 over 2. So you should already be in degrees. So go ahead and do the cosine with a little -1, so second cosine. And in your parentheses, you type in that ratio of square root 2 over 2. 45 is correct. Now we got to change that 45 into radians. It is pi over 4. Very good. And again, you probably are going to notice if you look at those triangles we wrote down. Tells you right in those triangles what those angles are, right? It does. So any questions in this section? Yes.
So it's just going to be like cosine and sine. It's not going to be like secant.
Oh, no, there is.
Oh, there is?
Of course. Okay, so let's do a secant one. Let's do the secant of, let's do the secant of 2. All right, so here's what I want to tell you. We talked about those ratios. What's special about the secant ratio and the cosine ratio? They're inverses, right? So I can really do the cosine of -1 of 1/2. Cosine of 1/2? 60 degrees. What is that in radians? Pi over 3. Very good. Yeah, you should really, I'm being lazy. You should have a degree sign there. All right, so we're good so far? Okay. All right, next section. Example number 3. In example number 3, you're going to be given a triangle. Let's say in that triangle you're given this side is 23, this is 39 degrees, and it wants you to find x. This you have done before. We have done this before. These problems are 49 through 53. You have done this, right? Right, you did it in geometry, and we did it right before break. So in this one, what 2 pieces of information do we have? What? Okay, let's keep going. All right, so from here we have the adjacent and we have the hypotenuse, right? So before break, remember we said adjacent was the cosine of 39 degrees was 23 over x. How did we go about solving this? We multiplied by x, so we had x cosine 39 degrees equals 23. Then what did we do? Divided. Very good. So x equals 23 over cosine 39 degrees. And you type that in your calculator. So x equals 29.5 what?
Oh, yeah, I'm in degrees.
You're supposed to be in degrees. Yes. How you know which trig function to do. Yep. Okay. And this is exactly what I said. This is exactly what I said before break too, and you wrote it in your notes. Look at the sides you have to decide which trig function to use. Okay? So in this one, from this angle, you have adjacent and you have hypotenuse. So the only basic trig function that's adjacent to hypotenuse is cosine. Right? If I were to give you, let's do another one really quick. Let's say I have this one, and in this triangle, I have a 34 degrees over here, 15 here, and I want to know x. Right? Yes. We have opposite and we have hypotenuse. Which trig function is that one? Sine. So we have the sine of 34 equals 15 over x. And technically you'd multiply by x and then divide by the sine of 34. Or x equals 15 over sine 34. Which equals, anybody got any ideas? Good. 26.82? All right. So those seem pretty easy, right? I have one more problem I want to talk about. One last one. And actually, where do I have you going to? 57? So it covers the last 2 problems. I'm sorry. Last 2 problems. In the last 2 problems, so example 4. This is 55 and 57. You're going to be given 2 pieces of information. You got to find the rest of it. So remember that when you have a triangle has 2 angles, angle A and angle B. Angle C is 90. We already know that. And it also has 3 sides, A, B, and C. Okay? So if you're given 2 pieces of that, you can find the rest of it, right? So if I told you angle A was 30 degrees, and that side A was 10. You just got to find angle B, side B, and side C, which again is just using the same stuff we just did. Okay? So I would fill it in my triangle. If this one's 30, what would that angle be? Good. If this side is 10, and let's find C first. I can go from this angle and do opposite over hypotenuse, or the sine of 30 equals 10 over C, right? You could. Yeah, it's only because I used an easy angle up there, but yes. So then, of course, this is C would be 10 divided by sine 30. You should get 20, exactly. All right? So then you can do the same process in order to figure out what B is. That's all you have to do. Okay? We're good? All right.